Hello Year 9, welcome to our last lesson on simultaneous equations. In this lesson we're going to be looking at graphical methods for solving simultaneous equations. It's an alternative to using an algebraic method, but sometimes it's not quite as accurate. So, all the equations that we've done so far, in all the lessons that we've done, can all be drawn. And when you plot them, they're all straight lines. These types of simultaneous equations that we've been doing are sometimes known as linear simultaneous equations for exactly that reason. So we're going to be drawing straight line graphs basically today and looking at certain properties of those straight line graphs. So let's have a quick look at example 1. Let's get straight in there with example 1. It says draw the graphs 2x minus y equals 5 and x plus 2y equals 5 and find their point of intersection. So first things first. Now I could draw full tables of values for both of those, but I don't really know how big my tables of values need to be, so I'm going to look at actually the points where the straight lines intersect the two axes. So they intersect the x-axis when y is 0, and they intersect the y-axis when x is 0. So I'm looking at those 2 points. So if I start with 2x minus y equals 5, so on the y-axis x is equal to 0, and if x is equal to 0 I get negative y is equal to 5. So y equals negative 5. And on the x-axis, the y coordinate will be 0. So going back to here, if y is equal to nothing, so 2x take away nothing is 5, 2x will be equal to 5, so x is equal to 2.5. So I have the 2 points where this straight line crosses the x and the y axis. I'm going to do exactly the same with the other graph, or the other equation. X plus 2y equals 5 on the y axis. X is equal to nothing. So if x is equal to nothing, 2y is equal to 5. So y is equal to 2.5, and on the y-axis, the x-axis, y is equal to nothing, which means that x is equal to 5. So I've got a pair of points that this line goes through and a pair of points that this line goes through, and I can now plot those points. I've now got some idea of how big my axes need to be. So I need to plot 0, negative 5 and 2.5, 0. Let's write them down as coordinates. 0, negative 5, 2.5, 0. So I'm going to plot those 2 points. 0 and negative 5 is down there, 2.5 and 0 is there. Those 2 points which I'm going to plot it, and I'm going to draw with my straight line. Join them up. Yep. And label the line. So that is the line 2x minus y equals 5. My other one here, my coordinates are going to be x is 0 and y is 2.5, so that's 0 and 2.5, and x is 5, y is 0, so 5, 0. So I'm going to plot those 2 points on the same axis. So 0 and 2.5 is there, and 5, 0 is there. My ruler, joining them up. Where are we? There we go. So this one is the line x plus 2y equals 5. So the question said, draw them, I've done that, and find their point of intersection. The point of intersection is the point where the two lines cross. So that is there. And that is the point 3, 1. And it says, what does this point represent? Well, that point of intersection is where both lines have got the same coordinates. Both lines have the coordinate x. On that line, x is equal to 3 and y is 1 on both lines. Which means that x is equal to 3 and y is equal to 1 satisfy both those equations. 2 lots of 3 is 6, take away 1 is 5, and 3 plus 2 lots of 1 is 5. So it works for both equations. And if that's the case, then that point of intersection is the same as the solution to the simultaneous equations 2x minus y equals 5 and x plus 2y equals 5. So you can find the solutions to a pair of simultaneous equations by drawing them and finding the point of intersection. That's great when the point of intersection happens to be on a grid line, but sometimes the algebraic version is better. So the point of intersection is the same as the solution to the simultaneous equations. Let's crack on and look at the next example. So I've blown up the graph, it's a bit blurry, but you can see what we need to see. It says use this graph to solve x plus 3y equals 8 and 2x plus y equals 1. The lines have already been drawn for you. If the lines have already been drawn, you do not need to go about using an algebraic method, especially if you can see them. So look for the point of intersection. So the red line, x plus 3y equals 8, intersects the bluish line, 2x plus y equals 1, at this point here. The coordinates of that point are negative 1, 3. So negative 1, 3. They are the coordinates of the point of intersection, which means the solutions to our simultaneous equation should be x is equal to negative 1 and y is equal to 3. But because we're reading from a graph and we need to be absolutely convinced that we've read it accurately, you should still do that check. So, as we've done before, x plus 3y is equal to negative 1 plus 3 times by 3, which is equal to 8. Negative 1 plus 9 is equal to 8, correct. And 2x plus y is equal to 2 lots of negative 1 plus 3 is equal to negative 2 plus 3 is equal to 1. Correct. So we've verified that x is equal to negative 1 and y is equal to 3 satisfies both equations, therefore they must be a solution to both equations. And you've solved it. Straightforward as that. Now, I would like you to do exercise 10E, which is on page 187. Try question 1 and question 2A and B first, and then check your answers. Once you've done that, have a look at the problem solving questions, which just questions 3, 4 and 5. Don't worry about question 6. That should take you the rest of this lesson. If you would like to hang on for a moment, I will have a look at a couple of the bits from question 1 and question 2, just as an extra example. But if you want to just get on with the work, keep going, and I will see you in the next lesson, which is going to be, I think, inequalities. So here is the first question from exercise 10E. I'm just going to do one part A. it says use the graph to solve these pairs of simultaneous equations. So in part A, I've got the pair of equations y is equal to x minus 1 and x plus y is equal to 3. Because the graphs are drawn, I'm going to look for the graphs of these equations. So x plus y equals 3. X plus y is this one here, and y is equal to x minus 1 is this one here, and I want to find the point where they cross. So the red and the slightly purplish one cross there. That point of intersection is 2, 1. So according to our graphs, the solution to the simultaneous equations, this pair here, is x is equal to 2, y is equal to 1. And we're just going to quickly check. So we have got in this one, let's do the right hand side, x minus 1 is equal to 2, take away 1, which is 1, which is y. Correct. And on this one, x plus y equals 2 plus 1 equals 3, which is the right hand side. Correct. So we verified that both those solutions work in both lines, so those are the correct answers. X is 2, y is 1. Very quick and easy to do if the graphs are drawn for you. On question 2, I would like you to do 2a and b only. So I'm going to do 2d as my additional example. So 2d says plot your own graphs in order to solve, and then I've got my equations are 2x plus 3y equals 12 and y equals x minus 1. So using that method of working out where they cross the x and y axes, so x is equal to 0 in this one, then 3y equals 12, y would be equal to 4. So I have the point 0, 4. And y is equal to 0, then 2x will be equal to 12, so x is equal to 6, so I have the point 6, 0. Make sure you get your coordinates the right way round. Let's plot those. 0, 4 is there, 6, 0 is there, join them up. And that's my line. 2x plus 3y equals 12. And my second one, y is equal to x minus 1. So x is equal to 0, y will be equal to minus 1, 0, negative 1, and y equals 0, then x minus 1 equals 0, so x is equal to 1, which gives me the point 1, 0. So plotting those points, 0, negative 1, 1, 0. Not very widespread points there, but you can see from the 2 points that you have got that you've got a gradient of 1 there, so we can just put them, can work out where the rest of them would be. So that's my second line. Y is equal to x minus 1, and you can see there is your point of intersection. So plot your own graphs in order to solve these pair of simultaneous equations. I haven't finished yet, I need the solutions. So solutions are x is 3, y is equal to 2, x is equal to 3, y equals 2. Do a quick mental check in here. 2 lots of 3 is 6, 3 lots of 2 is 6, 6 add 6 is 12, works. And on this one, x take away 1, 3 take away 1 is 2, which is y, so it works. You know you've got it right. So those are my extra examples using the questions. Remember, you're just doing question 1, the rest of the parts, question 2, A and B, and then questions 3, 4 and 5. So you've got about about 40 minutes of the lesson left. You've got plenty of time to have a good go at those. Remember to check your answers as you go, just in case you've made any mistakes, and if there are any problems, email your own class teachers. I'll talk to you next time.